Okay, now let's come to the next part of the topic. We are analyzing about how to find the domain and range of a function, the first part today. Then they have given a function just like this. Hx is equals to 1 over x. Right. So when you are working out with this, the 1 over x function today. So if you want to find the domain means if it is a function, if I sketch this graph, you can say the graph shape is like this, where at x equals to 0, the answer does not exist. For x equals to 0, answer does not exist. Therefore, you can write domain. X is any real number. You can say x is not equals to 0. Put the answers from your final number. So you can say number and it's not equals to 0. Yes, right. Then the range. Y values put it. This is a very important point. Basically, you can write hx is any real number, but there is a one condition today. When you are working out the y answers, look at this. Starting from plus infinity, it goes over here, and it's again stop from here, and it goes like this way. So you can say y equals to 0 also does not exist. Then you can say hx is not equals to 0. This would be the range for this function. Yeah, that's how it comes. So again, I think the color is not clear, so I just go with the blue color. So over here, 0 is not there, and it goes like this way around. That's how it comes. Right. And here you have to understand that this point 0 does not exist for this function. That's the important point for this kind of a situation. So that is the domain for this kind of a function. Right. Then I'll do a small difference for this. Yes. They might give you a question like this. They might give you hx is any real number and hx is greater than or equals to 2. Yeah, that's it. Just so if I sketch this graph with it, the question is find the range. Find the range. That's a question. Right. Right. So when you are working out with this today, if I sketch this graph, the graph exists. Usual graph is this way. But the graph exists from 2 onwards. Here, and if I put 2 here, it's 1 over 2. The graph goes up to here, including 2. 2 is included over here. Therefore, if you draw the y values, what are the y answers? Starting from half also included, then it goes down. But there is a condition where the 0 does not exist. The 0 does not exist for this function. Yeah. Then, yes. Therefore, you can say the 0 does not exist. Therewith that you can say this part of it. So you can write hx is any real number, and you can say hx vary from where to where? Starting from half, it come up to 0. Half is included, but 0 is not included. Therefore, you can say hx is greater than 0 because 0 is not included over here today. Right. But half is included. But here, if the equal mark is not there, half also not included in the answer. That is the next extension where we can see in this kind of a question. Right. They can ask you this kind of situations as well. Right. Then the next situation is just like this. gx is equals to 1 over x plus 3. If you want to find the range and the domain for this function. So what you can understand is today here, if I draw this graph at x equals to minus 3, the function does not exist. These are the alterations there they ask. So if you draw this graph, it's a shape like this, and it's a shape over here. Now you can see what are the x values. So you can say domain. Domain is x is any real number and x is not equals to 0. At 0, answer, x is not equals to minus 3. Sorry, I just made a mistake. Minus 3. At minus 3, the function does not exist. Right. Range. So you can say generally, you can say gx is any real number. Then what are the g answers today? If you come across here today, starting from plus infinity, the graph goes over here and here and here, but there is an exception here today. What is it? 0 does not exist. There is no answer. There is no y answer for 0. Sorry, there is no 0 y answer, not y answer for 0. There is no 0 answer as to obtain as y. Therefore, you can say gx is not equals to 0. It is a second part of the alteration where they can ask you from this kind of a question. Yeah. Then I will raise this one also. The other important part is today y equals to ax plus b over px plus q graph. Right. How many of you know how to draw this graph? Yes, we will ask from one by one. Oshadi, do you know how to draw this graph? Oshadi?
Not sure, sir.
Not sure. Madhushani, do you know how to draw this graph?
Maybe, sir.
Maybe, yes. Fadil? Yehen? Sanshia?
Not sure.
I don't think I can, sir.
This is the way. So anyway, we'll go ahead with this. Initially, the graph is like this. It has a horizontal axis of asymptote and it has a vertical axis of asymptote. This is horizontal axis of asymptote. This is vertical axis of asymptote. There are two axes of asymptotes are there. So it can be this way or sometimes this way also possible. That is kind of depends on the question only, we have to understand. Right? This is the way of it. Either the black one or the or this blue color one. That is the basic shape of it. It's not both. Actually, it's either this black one or this blue one. That is the one of it. But it's the basic shape of the graph. Right? Then let's see how to find the horizontal axis of asymptote. Sorry, it shall come with the vertical axis of asymptote. How to find it? Right. The way of finding this is make the denominator 0. Px plus q is equals to 0. Then what is the x answer? X is equals to minus q over p. So this axis of asymptote is x equals to minus q over p. Is that clear? Yeah. Right. How to find the horizontal over axis of asymptote? This is the way of doing it. This one you can get by this way. Y equals to coefficient of x in numerator divide by coefficient of x in denominator. That is the answer for that. Okay, and you can say y equals to, making it here now, what is that? A over P. This would be the answer for that. Okay. Yeah, from a graph, we will try to understand how does it comes. Okay. From a question, let's try to get it. How do we get the exact answer for that? From this graph, we are going to learn how to find the answer for this graph. Now let's try to go ahead from a question and try to understand how does it work. Right? Okay, this is one. For example, if you want to draw fx is equals to 2x plus 6 divided by x minus 4. Right, this is the way. Initially, we need to find about vertical axis of asymptote. How do you get it? Put it? X minus 4 is equals to 0, therefore x is equals to 4. Let's draw this. 1, 2, 3, 4. We'll draw this one. X equals to 4. Then we will draw horizontal axis of asymptote. Y equals to coefficient of x in numerator. What is the coefficient of x in numerator? 2. Divide by coefficient of x in denominator. Is how much today? 1. So y equals to 2 would be the answer for that. 1, 2. So you can draw this way. Right. This is y equals to 2. Now you need to draw the shape of it. To understand the shape of it today, we need to see whether the intersection with major axis. That is a clue of drawing this graph. Intersection with y-axis. How to make the intersection of the y-axis today? You can make x equals to 0. In this function, if you make x equals to 0, you can say y is equals to 2 times of 0 plus 6 divided by 0 minus 4. That is y equals to minus 1.5 would be the answer. So you can say here minus 1.5. The graph should travel through this point. Right. Then we need to see whether intersection with x-axis. How do we the intersection with the x-axis? Y is equals to 0. If you make y equals to 0, you can say 2x plus 6 divided by x minus 4 is equals to 0. That is 2x plus 6 is equals to 0. Therefore, x equals to minus 3. So it travels at x-axis from minus 3 here. Now the graph travels to this point. There you can draw the graph like this. So you can say it's a graph somewhere over here. It just goes like, if you draw it nicely, it's over here. It goes like this way. And this side of the graph is this. You can refer with the previous graph. My drawing is not that good. This is equals to 0, so it's like this. So it never touches this graph. My drawing is prepared. Yeah, now what you can understand is today, now we need to see the domain. For this function, I think you have already drawn this graph. I'll read this question part of it. If you define the domain and range for this kind of function, how are you supposed to do it? Right. Over here, I think you know these two figures. That is the range, domain. Domain means the input values. Domain, you can say initially, you can write any real number. And is there any exceptional figures where you have to omit from this answer? Yes. X equals to 4 does not exist. Therefore, you can say x is not equals to 4. That is the domain for this function. Then we'll go ahead with the range. range. So you can generally, you can write IST function as fx is any real number and fx. What you can say, Pute? You can see all the y answers are there. Here from infinity, it comes up to here. Again, here or downwards, all the y values are there. But here, this value does not exist. So you can say fx is any real number, but not t equals to 2. That would be the range for this kind of a function.